This is the lesson one. Well, it's the first part of lesson one about minerals. And so I have my notes here. And as I go through, I'll show you where in the notes that you need to be filling in. So first of all, when we started this, we should ask, what are rocks? Okay, you probably know what rocks are, and you've seen rocks maybe at your house. Maybe you even collected rocks, but I want to know, what are they? And before we can do that, we look at the definition here. A rock is any naturally occurring solid mass or aggregate of minerals or mineraloid matter. And I'll have this definition for you later because it is in your notes later, but you don't need to write this yet. What I do want you to see is this word minerals, okay? So what are minerals? If rocks are things that are made of minerals, you should know what minerals are, and that's what this part of the lesson is. So a mineral, you should write this here in your notes. A mineral is a naturally occurring solid that can form by inorganic processes and that has crystal structure and a definite chemical composition. This is on page 35. So if you want to pause and write down your definition right here for mineral, do that now. There are differences between rocks and mineral. They are not the same thing. A rock is a consolidated mixture of one or more minerals. So it is weird because in some cases, a mineral can be considered a rock, but not all rocks are just single minerals. That's confusing. Okay, so this is the connection you need to see. A rock, like granite, so this is some granite. Okay, granite is a rock and it is made up of minerals. So if you could zoom into that, you would find the mineral quartz. This is quartz, it's a mineral. And feldspar and biotite. Okay, it's really shiny, very thin mineral. So these three minerals, see how awkwardly I can hold them, if they can combine and make a rock, right? So little pieces of these things combine over time in different ways and make rocks. These minerals, and so like this quartz, is made up of silicon and oxygen elements. So if you remember the periodic table, they are made, so quartz is always going to be made up of silicon and oxygen. Okay. So mineral checklist, this is in your notes. And so right here, mineral checklist, you should write these 5 things down. All minerals have to have these 5 things. If they have 1 but not the other 4, they're not minerals. If they have 4 but not 5, they're not minerals. They have to have all 5. So naturally occurring, that means they happen in nature. They don't have to be made by people. Solids, crystal structure, inorganic, this means non-living. Okay, organic means living. So inorganic means it comes from non-living things, or has not, like, it didn't have to come from things that were once living. And it has a definite chemical composition. So if we look at our 2 examples, and this is in your notes, coal and quartz. Both of these things are solids. They are both naturally occurring. Coal does not have a crystal structure. Coal does not from inorganic things. It has some inorganic matter, but it also comes from decomposed once living things. So like plants and animals, when they die over time, enough pressure, they can combine and make coal. And it doesn't always have a definite chemical composition like our quartz. And so quartz would be because it meets all 5 of the criteria, but coal does not because it doesn't meet all 5. So there are lots of different minerals, and I have a mineral kit that you guys can look at in class. It includes the 3 that I've already showed you, but it also has some of these other ones. And so here are just a few different minerals that we can look at. And so how do we know which is which? And so there are 8 categories that you will need to know. And so this part of your notes, 1 of these 8 things, so like color will go in one box, streak will go in the next, and you might want to leave some space for some room. Color, that's, I think I have things for each of these. Yes. Okay. So color, it's kind of obvious. It's like, what color is it? And it says here, so this is an example, both look gold, but because they're both gold color. So color is a method that we use, but it's not the only method. So if two things are the same color, they don't have to be the same mineral because there's other properties. Streak is the color of its powder. So if I were to take this number 3 on my list is hematite. So this is a mineral hematite, and I take it on my paper and I pull it down. You can kind of see that it made little streaks on my paper. That's the powder that it leaves. Okay, not all minerals leave a powder. Luster, I just think of it as like how shiny it is. It's how well it reflects light off of its surface. And so you would say this is silky, waxy, greasy. They all have a different luster, how shiny they look. Okay, hardness. So how hard something is. I'm going to move this out of the way. Maybe I can. Okay, so the first one is talc. Okay, and so all minerals have a different hardness, and there's a way that you can test it using this Mohs hardness scale. And so what is it? It's a scale used to rank the hardness of minerals, and it's not like a definite quantifiable unit. There actually is no unit. It's just, you would say it's a 5 on the Mohs hardness scale. It's a 4, it's a 1, it's a 2.5, it's a whatever. And so how this works is you scratch the mineral. I put rocks, I messed up. But you scratch the mineral on something, and if that mineral scratches the thing, then it's harder than that thing. Okay, and so this is in your book, and so you'll want to look in your book, and you can fill this in your notes. Topaz, it can scratch quartz, but not corundum. So we need to figure out which of these would be quartz, and it says that it can scratch quartz. Well, we need to put quartz on there first. So if it can scratch quartz, once we know where quartz is, it's going to be after that. But it cannot scratch corundum. So it can't be here or here. Right? So topaz has to be here, or here, or here. Gypsum, a fingernail can easily scratch it. Okay? So calcite, a fingernail cannot scratch it. Here, a fingernail can scratch it. So our gypsum is going to go in between. So this is what gypsum is. So you can write gypsum on your paper for the second one. Does this make sense? If not, ask me for more help in class and I can help you. I'm going to skip this, but it is in the slideshow. So if you want to watch it, you can, if you think it would help you. No. Okay. Density. We talked about this a little bit. Density is mass divided by volume. Okay. So here we have two minerals or two rocks, and they both appear gold. Okay, they both maybe have the same they might have the same hardness. Something else that we can use to identify which is the density. So this has a density of 4.8. It would probably be grams per milliliter. And this is 19.3. And so this would be real gold because we know the density of real gold. This would be fool's gold. Cleavage or fracture. So if we were to take a mineral and split it, if it splits clean and there's like flat edges, we call that cleavage. And if it splits and it's like jagged, we call that fracture. So how it splits, that's another way we can figure out which mineral it is. And then there's some other special properties. Do they glow under UV lights? Are they magnetic? How do they interact with light? So like this calcite is pretty neat. I have some here. No, which one is my calcite? Number 6. Okay, so calcite, it's like clear, and this one's not as clear as the one on there, but if it's cut just right, it'll actually change how we see things. So kind of like how glass changes, it refracts light. Okay, so where do minerals come from? This is on my back. Oh yeah, so here's a Mohs hardness. Where do they come from? Right there. This is on page 40 to 42 in your book, so you can use that. Some come from organic processes, so like teeth, right? And our bones, those have organic minerals, so our body can use things and help make it. Some come from inorganic solutions, so water. If I have like a cup of water and the water evaporates out of the cup, or if I were to boil it, it can change those solutions, and that can make different minerals. Some form inorganically, so again, non-living, from magma or lava. So they can form in volcanoes. I'm not moving where I want to move. So you can write those down. And then this, I just thought this was an interesting graphic, and it is on page 43. And so you can look in your book if it's easier for you to see, but these are all the minerals on Earth, and what you'll notice is not all of the minerals on this list are even in the United States. There's some minerals that you can only find in certain places, and so that's why it's important for us to have good relationships with other countries so that we can import and export our minerals so that we can make different things. And so there's some questions in your notes that go with this graphic. So that is the first part of lesson 1.